In this video, I'm going to show you guys a few more examples on finding indefinite integrals, but these examples are more challenging now because we are gonna be using chain rule and all that, right? So before I get to those examples, I want to show you, just kind of review on you guys on finding derivatives. So here I have y is equal to 2x plus 3 to the power of 2, the whole thing to the power of 2. Now if I were to find the derivatives, dy dx, what I have to do is, before I even do anything, I need to realize that I have the inside is a linear function and the outside is a quadratic, right? So I have a linear inside my quadratic, which means if I were to find the derivative, I will need to use chain rule, right? So which means I'm going to start by the outside. So I'm going to have a 2, and whatever's in the parentheses, I'm not going to touch it, right? And then I'm going to differentiate the inside, which is a 2. So since I'm not touching whatever's inside, it will still be 2x plus 3. And when I differentiate the 2x plus 3, the linear function itself, the inside function, I'll get a 2. So my final answer will be 2x plus 3. And that's your answer. But just to kind of simplify it, I'll get 8x plus 12. So this is how we apply chain rule when we are finding derivatives. Now, similarly, in these 3 examples, we will need to take that into consideration, right? So let's look at the first one. I need to find the indefinite integral of x squared plus 1, the whole thing squared, with respect to x. So I need to think about this. This x squared plus 1 to the power of 2, I can kind of look at it as a box, right? So before, I need to think about what do I differentiate, and that will give me what I have over here, right? So I can think about this. There are 2 ways to do this. I can say, all right, so if I expand this, what if I expand this, right? Oh, sorry about that. If I expand this, I'll get the indefinite integral of x to the power of 4 plus 2x squared plus 1, the whole thing with respect to x, right? So when I expand the brackets, when I expand the brackets, I'm taking care of that exponent, and that makes my life a lot easier, right? So now what I can do here is I can find the respective term. So I can find the indefinite integral of the respective term, and which is a lot easier, right, than what I had before. So what do I differentiate to get x to the power of 4? That will be x to the power of 5 with a 1 over 5 in the front. What do I differentiate to get 2x squared? So that will be x cubed and 2 over 3, right? So because when I differentiate x cubed, I'm going to have a 3. The 3 goes to the front. With the 2 over 3, I'll get the 2, right? Finally, what do I differentiate to get a 1? Then that will be just x. And don't forget the plus c. All right, so that's how you do it. So try to always expand the brackets if you can, right? If it's not too much. In this case, we started with x squared plus 1. We ended up with only 2 terms, but after we expand the brackets, we have these 3 terms, which is not bad, right? Later on, we are going to use a method that's called substitution. So we are going to, which is kind of like an inverse chain rule, kind of, right? But for now, in this video, let's try to just simplify the expression, and so that we can find out indefinite integral easier. All right. Now let's look at the next one. So in this case, what I'm going to do is I'm going to cut it out. So I will have 3x squared over x plus 2x over x plus 1 over x, and the whole thing with respect to x. So now a lot of stuff can be simplified, right? So I'll have the indefinite integral of 3x, and then plus 2 plus 1 over x, and the whole thing with with respect to x. And I can cut this out. I can not cut it out. I can separate them. So I will have 3x dx plus 2 dx plus 1 over x dx. So it's a lot easier now, right? So x, which means it had to be x squared or before that. If I differentiate x squared, I get x. But I also get a 2, so I need to take care of the 2 and put the 3 up there, right? Plus, what do I differentiate to get 2? That will be 2x, right? And this part, what do I differentiate to get 1 over x? That is simply my ln x, right? And finally, don't forget the plus c. All right. I hope you guys are following so far. All right, let's look at the last one. So the last one seems very complicated, right? But it is pretty much testing us on our knowledge of the natural log and the exponential, right? What happens when I put an exponential function inside a natural log? What happens? Or if I have exponential function, or if I have something like this, e to the power of ln x, what does that become? Since they are inverse of each other, I will always get whatever is up there, right? I always get that. So if I have e to the power of 2t minus 1 inside the ln function, they kind of cancel out each other, right? So I will be left with only 2t plus 2t minus 1. Does that make sense? This is sort of like a review of what we did in chapter 4, exponential functions and logarithmic functions, all right? So by doing this, it is the same thing as saying finding the indefinite integral of 2t minus 1 with respect to t. So this is so much easier now, right? So now this becomes the indefinite integral of 2t with respect to t minus 1 with respect to t. So what do I differentiate to get 2t? That'll be t squared, right? Because when I differentiate t squared, the 2 goes to the front, and then I get a perfect 2t. What do I differentiate to get 1? That will be minus t. Sorry, the minus is just minus, right? What do I differentiate to get 1? That will be t. And finally, don't forget your plus c. All right, so the rules that we learned before about inverse, that might come in handy, okay? As you guys see here, the relationship between your natural log and exponential, that helps us to simplify our equation a lot in this example. All right, we're gonna come over more advanced examples in the next video. For now, if you have any problems, please clarify with me in class, okay? All right, I'll see you guys in the next video. Bye-bye.